Welcome to the third video of the GATE-ECE. Today we are going to discuss about network theorems, DC and AC excitations. So the most popular network theorems are listed on the slide. They are superposition theorem, Thevenin's theorem, Norton's theorem, maximum power transfer theorem, reciprocity theorem, compensation theorem, Millman's theorem, concepts of duality and dual network. The textbooks that we can refer are William Haight and Jack E. Kemmerly, Engineering Circuit Analysis, McGraw-Hill Company, 8th edition, 2015. This is a major textbook which is highlighted in red. Other textbooks are C.L. Wadhwa, Network Analysis and Synthesis, New Age International Publication, 3rd edition, 2018. Charles K. Alexander, Matthew N. O. Sadiko, Fundamentals of Electric Circuits, Tata McGraw-Hill, 6th edition, 2019. These are the major three textbooks that we are going to refer for our analysis. Today, in Module 1, we will be discussing about importance of network theorems. Network theorems are used to reduce a complex circuit to a simpler one, thereby making the circuit analysis much simpler. So, if you want to analyze complex circuit, but in a simple way, then we can use network theorems. The first of the theorem is the superposition theorem. The superposition principle, which is the base of superposition theorem, it states that the voltage across or current through an element in a linear circuit is the algebraic sum of voltages or currents through that element due to each independent source acting alone. That means if we have more than one voltage source or more than one current source in a linear circuit consisting of resistors, then the algebraic sum of the voltages across that element due to independent sources acting alone is nothing but the voltage across the element in the linear circuit. So, we will analyze this statement using the circuits. So, this is just the definition. So, no need to worry much about this. The principle of superposition helps to analyze a linear circuit. So, very much important for linear circuit with more than one independent source by calculating the contribution of each independent source separately. So, if there are many independent sources, then we can analyze the circuit using superposition theorem by analyzing the contribution of each source. So, two things have to be kept in mind. First, we consider independent source at a time when all other independent sources are turned off. So, if many independent sources are there in the circuit, only one should be kept, others should be turned on. This implies that we replace every voltage source with zero or short circuit. So, when we are analyzing one voltage source, when there are many, other voltage source should be made zero and other current source should be made zero. So, voltage source can be made zero by short circuiting it and current source can be made zero by open circuiting it. Different sources are left intact because they are controlled variables. So, dependent sources are left intact. So, There are two types of sources, independent and dependent. Dependent means it is dependent on some variable like time, voltage, current, etc. So if voltage is dependent on time, it is a dependent source. If it is not depending on the time, it is independent source. So we will move on to the next slide. How to apply superposition theorem. So all independent source except one should be turned off, means you have to make 0. Find the output, that is voltage or current due to that source. Repeat step 1 for other sources. So if there are two sources, first source is made 0, analyze using the second source, and after that second source is made 0, analyze using the first source. So the final total contribution by adding all the contributions due to independent sources will give the effective voltage or current. Okay. So an example of superposition theorem is given here. So here you can see in the first circuit, 6 volt battery, 8 and 4 ohm resistors and 3 ampere current sources connected. So this arrow indicates current, plus and minus is voltage, and these two are two resistors, fixed resistors, value is fixed at 4 ohm and 8 ohm. So 6 volt, first we have to make 3 ampere 0 by open circuiting this. So it is removed now. So you have 8, 4 and 6 volt. So we have to find the voltage V1 using the superposition theorem. So how to find the voltage? So 6 volts, we can use the KVL, Kirchhoff's voltage law. So that will be explained later. Okay. So what is Kirchhoff's voltage law? Total voltage in the loop is 0. So 6 volts plus voltage across 8 ohm plus voltage across 4 ohm, together in this loop total voltage is 0. So 6 by 8 plus 4 will give the current by Ohm's law. Ohm's law states that current is equal to voltage by resistance, or voltage is equal to current into resistance. V is equal to IR. So 6 divided by 12. 8 plus 4 is 12. 6 by 12 is 0.5. 0.5 ampere current flows in this loop. So I1 you can see here, that is 0.5. How I got 0.5? I am finding out the current in this loop. So I am adding two resistances. This is open. So 8 plus 4, 12. 6 by 12 is 0.5. Voltage by resistance as per Ohm's law. So I get 0.5. So what is the voltage across 4 ohm? The voltage across 4 ohm is 0.5 into 4, that is 2 volts. 2 volts is developing across the resistance R1, or V1 or V is 2 volts. Now next step, make 6 volt 0 and keep this 3 ampere. When I make 6 volt 0, when I open circuit this, current will not flow through the 8 ohm. But current will flow only if I short circuit this. So this I have open circuited, this I have to short circuit, means I have to connect a wire here. So you can see here a wire is connected here, but here it is open, this is open here. So a short is made between 8 and 6 volt. Okay, so 3 ampere is the current. So if 3 ampere is the current, I2 flows through 8, I3 flows to 4. So what is the current division? Total resistance is parallel combination of these two, 8 into 4 by 8 plus 4. 8 plus 4 is 12. 8 by 12 is 2 by 3. So 2 by 3 is a resistance. So current is 3 ampere. So what is a current division? So current division is calculated by total current into the current which you want to calculate. Say if you want to calculate current through 4 ohm, then 3 ampere into 8 by 4 plus 8. That is given here. So how to calculate or how to do current division? So current in this source is 3 ampere. So current in 4 ohm is total current into resistance of the other arm by total resistance. Total resistance is 8 plus 4, 12. So 4 by 12, that is 1 by 3 into 3, 1 ampere. So 1 ampere current flows through 8 ohm. So how to calculate current through 4 ohm? 3 ampere into 8 by 4 plus 8. That is 3 ampere into 8, 24 by 4 plus 8, 12. So 2 ampere flows through 4 ohm. 2 ampere here, 1 ampere here. Together 3 ampere. So this is how you calculate the current or the voltage in each arm. So when 2 ampere flows here, 4 ohm into 2 is 8 volt. So we have 8 volt here and we have 2 volt here. So what is the total voltage? 10 volts. It is adding. Look at the polarity. Direction of current is down. Direction of current is down. Both side same direction current. So voltage will add. Voltage will add. So this is the voltage. This is the voltage. V1 is the voltage due to current. V2 is the voltage due to the current I3. So here you are getting 8, here you are getting 2. So together 10. We will solve one numerical using superposition theorem. Say in this given circuit there are two independent voltage sources, 20 volt and 4 ampere current source, and another voltage source 5 I naught is dependent on the current I naught flowing through 5 ohm. So altogether 3 sources are visible from the circuit. You can see the circuit. 5 ohm and 3 ohm, two resistances, 1 ohm and 2 ohm, another two resistances. 20 volts is a fixed voltage source, 4 ampere fixed current source, 5 I naught is a variable current source. In fact, I naught is a current, 5 I naught is a voltage source because plus and minus. Okay, how do we analyze this circuit using superposition theorem? So as per the superposition theorem, only one source needs to be maintained, other two sources have to be made 0. But it should be noted that phi I naught is a dependent source, so you cannot make it 0 because I naught is not 0, phi I naught cannot be 0. I naught value is not known, so you cannot make it 0. So phi I naught cannot be 0. So only 4 ampere and 20 volt sources can be made 0. So in the first part of the analysis, we make 20 volt source 0 by shorting this wire, by shorting this source using the wire. So here you can see it is shorted here. So other things remain the same. So this loop is renamed I1. This loop is renamed I0, sorry I2, and this loop is renamed I1. Okay, yeah. So we do KVL analysis, Kirchhoff's voltage law analysis for loop 2, which is this loop, and loop 3, which is this loop, and this is the loop 1. So how do we write the KVL equations? So all voltage drops are represented as negative, all voltage rises are represented as positive. So voltage drop means decrease in voltage. Voltage rise means increase in voltage. Plus and minus sign is used. So in loop 2, if we use current minus 3I1 because the current is flowing downwards, plus 6I2 minus I1, I3 and minus 5I0 together is 0. So how do we get this equation? Loop 2. So minus 5I0. So that is this one. So plus and minus is shown here. So current direction is opposite to plus minus. It is from minus to plus. So you have minus 5I0. Minus 5I0 because we see the direction of the current. If it is opposite to the direction of the current, we write minus. If it is in the direction of the current, we write plus. Okay. So minus 3I1 and minus okay. So you have 2 ohm resistance at the top, 3 plus 2, 5 plus 1, 6. So I2 direction is opposite to I1 direction. So minus 3I1 plus 6I2. So if I1 direction is taken negative, I2 will be opposite to I1, so it will be plus. So minus 3I1 plus 6I2. I3 direction, again I3 direction is opposite to I2, so it is minus again. So you have to look at the current direction. I1, I2, I3 are the 3 currents. So compare the directions. I1 is downwards, I3 is upwards, I2 is also upwards. So if you look at the loop, so it is flowing upwards. I1 is flowing downwards, I2 is flowing upwards, I3 is also flowing upwards. So look at the direction of the current. So how to mark the direction of the current? Depends on how you want. So if you write like this, then this is the equation. If you write in the opposite direction, then the equation changes. Okay. So depending on the direction of the current, you write the KVL equation. Okay. Loop 3. So loop 3 is this one. So you have minus 5 I naught dash because plus to minus. So voltage drop 5 I naught, but it is opposite to I1. So it is plus 5 I naught in loop 3. I1, I2, I3 and I naught. 4 currents are there in this loop. So I3 direction is taken in loop 3. Loop 3 minus 5 I1, minus 5 I1, minus I2, 10 I3. How do we get 10? So 5 plus 4, 9 plus 1, 10. So 10 I3. I3 is positive plus 5 I naught. So voltage drop here in this equation they have taken positive. Voltage rise is taken negative. So that is visible from KVL. Okay. But at node 0, this is a node 0, you can apply KCL because at the node you have three currents, 1, 2 and 3. Total current at the node is 0, that is KCL, Kirchhoff's current law. So you can apply Kirchhoff's current law. Total volt current at this node is 0. So you can see I3 is entering the node, I0 is also entering the node, but I1 is leaving the node. So total current is 0. So I3 divides I3 is nothing but I3 plus I0 is equal to I1. So I3 is equal to I1 minus I0. So depends on the direction you are taking. So anyway you can write. So current entering the node is taken positive here. Current leaving the node is negative here. So depending on the equation you can write. So I1 is given to be 4 ampere in loop 1. So what is I1? 4 ampere. This is 4 ampere. I1 is 4 ampere. So I1 4 ampere. So you can substitute here. So I2, I3, I0 will remain. I2, I3, I0. Solving this equation, we'll get I0 is equal to 52 by 17. Okay. So how do we get that? I3 is equal to 4 minus I0. That is the equation by solving this. So substitute I3 value in this equation, in both equations, loop 2 and loop 3 equations. So I3 is equal to 4 minus I0 dash. So this I3 will go off. These both I3 will go off. So I1, I2 and I0 will remain. Okay. But I1 is 4. So I gain 4 and 5. Here also I1 will go off because it is I1 is 4 ampere. So what remains is I2 and I3. I2 and I3. Solving you will get I0 dash is equal to 52 by 17. I3 is 4 minus I0. So that if you substitute you will get I0 is equal to 52 by 17. So gradual calculations. So it will take time, this solving of the equations. But you should be careful while writing this sign. That is important. If the sign is wrong, the answer will be wrong. So you have to keep the sign in mind. Similarly, this source is retained. This source is made 0. How to make this source 0? Open. So I have made this open and this is retained. So this one is a dependent source. So only two loops I have got. Loop 4 and loop 5. And solving the equations, you can write the equations on your own. Okay. So you apply KVL and write the equations. How to write the equations? So 2 plus 1, 3 plus 3, 6. So 6I4. So I4 is this one, 6I4. And this one, 5I0. And I5 is flowing here. I5 is flowing through 1 ohm. So minus I5. So sign depends on how we are writing the current. Loop 5 again. Three currents, I0, I5 and I4. So I have written the equation. Minus I4 minus I4 10 I3 10 I3. How do I get 10? 4 plus 5 9 plus 1 10 10 I3 minus 20 plus 5 I0. Total voltage in this loop is 0. KVL. Here also total voltage is 0. So I have the first equation, second equation. Simplifying. Okay. So what is I naught double dash? I naught double dash is nothing but it is I phi. I phi. So what remains? I4 and I naught remains. Two equations you can solve and get minus 60 by 17. So adding both you will get 8 by 17. So that is 0.407, 0.4706 ampere with negative sign indicates the direction of the current is opposite. It is not downwards but it is upwards. So this is a simple circuit. It looks complex but it is a simple circuit. So it is easy to analyze and simplify. The second problem, you have to find I. The circuit is given. So you have three sources again, 12 volt, 24 volt, both are independent, and 3 ampere current source that is also independent. So it is an easier circuit compared to the previous one. So how to solve this? There are three sources. So what you do, retain one source, make the other two 0. See here, 12 volt is retained, current is made 0, so you open this, and voltage is made 0, you short this. So this is a circuit. So simplify, you will get this circuit. How to get this circuit? So you can see 4 ohm and 8 ohm is in series, so together 12 ohm. 12 ohm parallel 4 will be 3 ohm. So 12 volt and 3 ohm, and this is 3 ohm, together 6 ohms. 12 by 6 is 2 ampere. 2 ampere downflow. Next, 24 is retained, other two are made 0. So voltage source is shorted here, so that you can see here, and 3 ampere current open, that is open here. So analyze the circuit. How to analyze? So this is open, so 4 ohm and 8 ohm together, it will be 12 ohms. Okay, but there is 4 ohm and 3 ohm here, 4 ohm, 3 ohm, 4 ohm and 8 ohm. Okay, analyze this circuit. Then after that, the third one is 3 ampere. So keep this, make these two voltages 0. So just short this. So here you can see shorted, and this is also shorted. So this problem is not solved. So you can solve this on your own, and if you have any problems, you can simplify and comment in the comment box. Okay. Okay. This circuit also is not simplified. Here you have got three sources, independent 25 volts, independent 5 ampere, dependent 0.1 Vx. So Vx is the voltage here. How do we solve this? So this voltage is a node voltage Vx. It is not known. You have to find that. But 0.1 Vx is given here. It is a current source. How to solve? This cannot change. So only two sources can be used, 25 volts and 5 amperes. So first make this 0, short this, and keep this. Find Vx. This will be 0.1 Vx. Apply KVL. Okay, then keep this open. Use this circuit. So you can use KVL. Okay, and find Vx. Whatever Vx value you get, that is the answer. Okay. Okay. Another circuit using superposition theorem. So here you can see 5 ampere current source and 20 voltage source, 20 volt voltage source. So same way, but this is a AC circuit. So be very careful while solving the problem. The solution is given. You have to calculate Z, then you have to calculate I naught. I naught is required. What is I naught? I naught is a current through 20 volts. So it is leading by the current by an angle 90 degree. Source is leading by an angle 90 degree. Okay. Same way, calculate Z. Once Z is found out, you can calculate I, because what I have done, I have made this open. So when that is open, I have only this source and this. So these two will add, this and this will add, and it is in parallel with this. Then you get the resultant circuit that will be added to this capacitor and 4 ohm, and finally you can calculate Z. So this is written in a complex way. It is not in steps, but I hope you can solve this. Okay. So how to solve? So you have to find a Z. So effective impedance. So these two will be in series, in parallel with this, then series, and then series. And once you get the Z, 20 by Z is I. So it is in polar. So here you can see complex values. You can convert it into rectangular or polar, and you can simplify. Okay, once this is made open, now this you have to keep and this you have to short. So that is shown here. This is shorted here, and this is kept. So same way, 4 is parallel with these two. So this one, 4 ohm is parallel with this. How to solve? Simplify this. So J10, you can use KVL, because KVL is much simpler instead of analyzing. So write 3 currents in the 3 loops, write equations, mesh equations or loop equations, and find the current I1 or I3. I3 is required. Once I3 is found, you can I3 in loop 5, sorry, loop 3. It is 5 ampere. So this 5 ampere here. Okay. So you can evaluate I3 in the first two equations, that is 5 amperes. So what remains is I1 and I2. Only 3 loops are there, I1, I2, I3. I2 is 5. So I1 and I3, sorry, I3 is 5. I1 and I2 is the other two. Two equations, two variables, you can simplify. You will get I2. Once you get I2, you can get I0. So I naught is the sum of these two currents. Add them. I naught plus I naught. So together. You can write it in polar. Okay. Easy it is. Looks complex, but it is simple. Thing is, you should know KVL and you should know how to solve. Which to retain and which not to retain. Exercise problem 4. Same way, superposition theorem. Again, 3 sources. One is a cosine source, one is sine source, and another one fixed source. So these two sources are dependent. This is independent. Same way you can solve. So you cannot change these two because it is dependent on time. Only one source is there. So you can solve this.